In this problem, we are to solve for the concentration of Fe3+ ions in an electrochemical cell. Specifically, this is a galvanic cell. Concentrations of other species are given, and the actual cell potential is given as 0 volts. I'm going to guess that copper is what's being oxidized. If we look in Appendix F, you can find the reduction of copper at plus 0.342 volts. Therefore, the oxidation would occur at minus 0.342 volts. If that's the oxidation reaction, then the reduction reaction must be from Fe3+ to Fe2+, and you'll find that in Appendix F at plus 0.771 volts. In order to calculate the overall cell reaction, which we'll need later on in the problem, I'll need to multiply the reduction reaction through by 2 so that both the oxidation and the reduction have 2 electrons. Note that when I did this, I did not multiply the reduction potential by 2. The overall reaction then is the oxidation of copper and the reduction of Fe3+ to Fe2+, and the standard potential for that reaction is plus 0.429 volts. Now I know I have these reactions oriented correctly because the question says that this is a galvanic cell, and galvanic cells always have positive standard potentials. So how do we get the Fe3+ concentration? Well, it's going to be part of the expression E equals E0 minus 0.0592 volts divided by N times log Q, where Q is the reaction quotient, and that contains the concentrations of species in this reaction. So this is known as the Nernst equation. I'm going to rearrange this to find a value for Q. Log Q is N over 0.0592 times the difference between E0 and E. So Q is 10 raised to that power, and we have values to substitute in. N is 2. The standard cell potential is plus 0.429 volts. The actual cell potential is 0 volts. And Q works out to 10 to the power 14.5, which is 3.11 times 10 to the 14. The actual formulation of Q is concentrations of products divided by concentrations of reactants, each raised to their stoichiometric powers, leaving out any solids such as the copper metal on the left. So now I can rearrange this to solve for the unknown. The Fe3+ concentration squared will have this value, and I have values for copper plus 2 and iron plus 2 and Q. Therefore, Fe3+ squared is 3.21 times 10 to the minus 15. If I take the square root of that, the Fe3+ concentration is 5.7 times 10 to the minus 8 moles per liter.